Hi, I'm Efe ERTÜRK from Bilkent University Computer Engineering Department, and today I'm going to be presenting you my Physics 101 lab project. So, to start with, the title of my project is calculating the kinetic coefficient of the paper when the pedals are pressed using conservation of energy. Okay. First, I'm going to talk about the materials I have used. I have used a wooden block to ensure a height and inclination of the air table. Of course, I have used an air table. I have used an angle meter to calculate the angle of inclination. I have used a puck. I have a ruler and I have a spring. So I'm going to first demonstrate the experiment, then I'm going to talk about the physics of it. So the puck is released from the top of the table, and it will compress the spring and it will cover some distance, and this is the maximum point that the puck reaches. So if I demonstrate, I'm going to do it right now. As you can see, the pedals were pressed, and also if the pedals were pressed, it is assumed that the coefficient of the table, kinetic coefficient of the friction of the table is assumed to be 0, but as you can see, if it were 0, I would expect it to bounce all the way up, but as you can see, it doesn't bounce all the way up. So there are three critical points in our experiment. The first point is this, the initial point. The second point is this, when the puck compresses the spring. And the third point is this, when the puck reaches its second maximum height. So I'm going to talk about the physics now. When the puck is here, it has only the potential energy coming from its height from the ground, or for our 0 point. So when it compresses the spring, it will have the elastic potential energy of the spring, and also it will lose some energy due to the friction of the paper along this path. So in the third point, it will also have the potential energy coming from the height of the object, and it will lose some more energy due to the friction in this path. So what I did in my experiment is that I have measured the distances, the d max, the distance between the initial point and the compressed point of the spring, and d1, the distance between the compressed spring point and the maximum height that it reaches. And just by calculating these values, I have obtained the kinetic friction of the paper, and the formula is that the kinetic friction of the paper is tangent alpha. Alpha is the angle of inclination, and it will used in many different areas. I will measure it in here. I have tangent alpha times d max minus d1, and divided by d max, the maximum distance the puck travels, plus d1, the second maximum distance the puck travels. So as you can see, I have experimented this in the eyes of you, and I did this experiment 3 times in every angle. I make sure that the bouncing is straight up, like no horizontal movements. 3 times in every angle, and as you can see, it has 3 different sides. So I have 3 different angles of inclinations. But in my experiment, I have shown that the kinetic coefficient of paper does not depend on the height of the inclination or the angle of inclination. So I aim to calculate and measure the kinetic coefficient of the paper, and I have used by just measuring some simple distances and an angle in my experiment. Thank you for watching.